Hello and good day. Today I'm going to share to you how to tackle these questions. Um, it says that suggest the mechanisms for the reactions between 2-chlorobutane with iodine ions or iodide ions. You have to draw the step involved, including the following. So you have to mention the lone pair of electron and dipoles, curly arrows to show the movement of electrons pair and the structures of any transition states or intermediate. So first and foremost, you have to check whether you still remember you have a SN, either SN1 or SN2. SN1 stands for substitution nucleophilic 1, while SN2 stands for substitution nucleophilic 2. Okay, so meaning for SN1, you will have two steps of mechanism, all right? And then while SN2, you only have a one step of mechanism. All right, so this is two and this is only one step. All right, so without further ado, I will show you how the structures of 2-chlorobutane. So from its name, you have a but, so it means that you have a 4 carbons, 1, 2, 3, 4. And then you have a chlorine or chloro in carbon number 2. All right, so I will have a CH3 here, and I have H there, and then this one is H2, all right, and then this one will be H3. So basically, I can use also three-dimensional structures for this one. Then if I convert that one, then I will have a, let me just give number so it will be easier for you to trace. So this is carbon number 1, carbon number 2, carbon number 3, and carbon number 4. So it is actually evident that we have a chiral carbon in carbon number 2, meaning because carbon number 2 has different atoms, so H, CH3, Cl, and I also have this one is actually C2H5, which is ethyl. So this carbon number 2 is actually chiral carbon. So I can basically draw the structures of this one, the 2-chlorobutane in the form of CH, let's say Cl here, right? And then here, for example, I have a C2H5, right? And then I also have a, for example, I have a, let's say this one is CH3, all right? Or this one is, for example, this one is H, all right? So it's also possible for me to flip this one, all right? So let me flip this one. Cl, and this one I have a Cl3, CH3, sorry. So I put here, I have a CH3 and I have Cl. All right, now with iodide ions actually I minus, all right? So I have to meet the lone pairs. So here, because I have a Cl and C in this 2-chlorobutane, meaning there will be different polarity between chloro and carbon. All right, so meaning I will have a two dipoles, which is dipole negative of chlorine, and I have a dipole positive of carbon. And then so I already made this one. Okay, so wait, I also need to show you this one. I is actually 1, 2, 3, 4, 5, 6, 7, 8 negative, because it is actually iodide ion. Iodide or iodine is located in group 17. So whenever it turns to IDE, meaning iodine gains 1 electron to give iodide. So I will have this structure, I minus. And then, of course, the curly arrow goes here to Cl because C is less electronegative than Cl. So you can also approach this one. So for example, if I pick SN1, then I will have the intermediate state, which is CH3. Okay, so, sorry, I'll just use the other color. Let's say I have to be consistent. All right, so let's say I use a black color. All right, so meaning I have a this one is CH3, and then this is C2H5. All right, and then this one I will have a I. Okay, so this one is still remains H, and then I have a plus here, and then I minus is already there. Okay, already there, and then I have a Cl minus here. Then I minus will attack this one. All right, so okay, I minus will attack this carbocation. Then I will have this structure. Okay, so I will have the this structure. Okay, so C2H5, C, CH3. All right, and then I have a I here, and then I have a H. Sorry, this one I still have H. All right, so this process from A to step B, it happens in slow step, but from B to C, so let's say this one is C, it happens very fast reaction. So I now have this one. Okay, so meaning if you have to check your conditions here, the requirement that given in the equation, you have to state the relevant lone pairs and dipoles. All right, and then you have a curly arrow. Okay, dipoles here I already mentioned. I have dipole positive and negative. Okay, check lone pair. Yes, I have lone pair of electron. Curly arrow to show movement of electron pair. So this one is already clear that electron from from this bond pair between C and Cl goes to Cl. All right, and then the structure of any transition state. So this is actually the transition state. Okay, so the transition state is this one. All right, and then it goes here. So this is actually the product. The other alternative uh, pathways actually you can also pick another reaction. Okay, so I'll show you the other one. For example, I have a 2-chlorobutane. Okay, so 1 CH3, and then this is C2H5, and this one is actually Cl. Let's say this one is H. So if you pick step SN2, meaning that you only have one step, then one step meaning that you have a I minus here. All right, so you have a minus, and then you have a lone pair of electron, and then of course, because Cl is more electronegative, then you'll have a dipole positive and dipole negative. All right, so then you will have a transition state. All right, so you can actually put like this C. All right, and then you have a I, and then you have a Cl here. All right, and then it can be like this one also, H, and then this is CH3, and then this one is actually C2H5. All right, so this intermediate is actually negative charge because we have an extra electron from I. All right, then this one goes there. Okay, and then you will have a the other product. Please note, in this case, is actually the when you draw the structure, this one should be, sorry, excuse me, yeah. So the length of this one, okay. Wait. So this one's supposed to be 180. Okay, so when you draw this one, is try to put you have a horizontal line like this and then vertical line. So it is actually 180-degree because that's the happen actually in the scale of molecule. Then this one breaks. All right, so let me put another color. So this one later will be breaks. All right, and then you'll have a same CH3, C2H5, and then you have a I, and then you'll have I. Sorry, H. Excuse me. So this is actually H. All right. So you might use SN1 or SN2. It is actually okay as long as you fulfill this requirement. Lone pairs and dipole, movement of curly arrow, right? And then any transition state. So this is actually the intermediate state. So this is actually the product file. So final product. Okay. So this is actually SN2 because you only have a one step that. Okay. So you only have this transition. I hope you learned something from me today. Thank you for watching, and